Hello, this is Mrs. Spellman. Welcome to GCSE Computer Science. Let's get started. So the bigger picture, we are looking at memory and storage. In particular, compression, and these two bullet points here. So do pause the video and take stock of where your knowledge is right now. And once you're happy you've done that, if you fill out the slip in your green book. Compressing a file is just making the file smaller. So the original file and the compressed file. And then we can take the compressed file and restore the file. What we're going to be looking at in this video is we can compress a file and restore it, and it can have the original quality, or we can lose quality when we compress a file. So this is an example of losing quality when we compress a file, so when we make the file smaller. So as you can see, this picture here has a quality scale here. So it's top of the scale here, and that's 580 kilobytes. And when I slide that to the lowest quality, it's only 44 kilobytes to store. So looking at that again, the higher the quality, the higher the file size. The lower the quality, the lower the file size. So by going for a very low file size here, we're losing quality, and that is an example of lossy compression. It's not that obvious with some, even though there's quality loss, sometimes it's not that obvious. So in this example, when I actually saved the file with a lower file size and the least quality, I actually couldn't tell the difference, but sometimes you can. So why would we make files smaller if we're going to lose quality? What's the point in doing that? Well, for one, we would need less storage space for a smaller file size. They're also quicker to transfer if they're smaller. However, we may lose quality. Back to this picture we used a few videos ago, and a reminder of what a 3-bit color depth means. So, for each pixel on this image, we need 3 bits just to store that particular pixel. So the size of the file altogether then is that 3 bits times the dimensions, so times 25 times 25, which here is 1875. Now this is going to be an example of where we can make the file smaller and yet keep the original quality. Now I know this is a low resolution picture. You wouldn't think it's great quality. However, we can apply a compression algorithm to this called run length encoding. And then when we restore the file that has been compressed, we can get back to this original standard. So let's look at that. So the idea of run length encoding is, for example, in this picture, there's lots of colors that are the same running alongside each other. In fact, there's 25 whites in this row, 25 white pixels in this row, and then 4 more. So altogether, from there to here, there's 54 white pixels. Then we have 4 black pixels, and then a further 9 whites. So we could actually write this out as a code as to how to reconstruct this image if we wanted to. And the benefit of that is, originally, this is how we're storing the data. So a white is 001 bits, 3 bits. 54 whites takes all of this data here. So I've basically written down 001 54 times, really I did, okay? So that's a lot of space, but we know that it's 54 whites. So what we could have done was just put the denary number 54. So the first 8 bits here is just the denary number 54, and then the code for white. So we've taken all of that and compressed it down to there, but we haven't lost the quality. We still know that means 54 white pixels. So that's an example of lossless compression. This is another example of lossless compression. So here I'm giving you a load of numbers, and they all can be stored in just 8 bits. And I'm also giving you what's called a dictionary table. It's all part of dictionary encoding algorithm for compressing files. Now, if I look here, I've got 9. So 9 means there, if you look in the table. Then I've got 10, and 10 means are. So there are, and then 14 is 2. So there are 2. 11 is different, and so on. You can see I can reconstruct this paragraph as it was originally intended. Now, if I wanted to be perfect in this example, I would have shown you the first word with a capital letter, but you get the idea here. So let's see then. You might want to pause the video and have a go at decoding this message. But I'm going to show you the answer. I'm going to show you what that paragraph is. So this is the paragraph that was represented by those codes. So let's look at the first word here. T-H-E-R-E. 5 letters, 8 bits each to store, 5 8 are 40. So we would need 40 bits to store just that word. However, 9 is the code for there, and for 9, a number, we would only need 8 bits. So that's an example of something that should take 40 bits to store, but now we're going to do it in 8 bits. So that means we can have a smaller size of file, and yet we can reconstruct the original file using the table that I've shown you in the last slide, and we can reconstruct it perfectly. Now, lossless compression, we have to have that for certain types of files. If it's the works of William Shakespeare and we want to compress that file so that it's faster to email to somebody, it's no good if that loses data along the way. We need all the words intact for it to make sense to somebody. Whereas with an image, sometimes we can get away with a loss of data because the human eye can't really see the loss, or we're happy to go with a less quality in that example. Okay, so looking at lossy and lossless alongside each other. Lossy compression is a smaller file and it loses quality, so data is removed. So lossy means loss of quality, but it typically has a very small file when we apply lossy compression. Lossless, again, of course it has a smaller file, it's been compressed, but not as small as a file that you would get with lossy compression. However, the benefit of using lossless is you keep the quality, and sometimes you need to do that. So you're going to go for lossless if quality is key, but you're going to go for lossy if the size of the file is key and you're not worried about losing quality. In the exam, you will not be expected to understand or apply these algorithms, but you just need to be aware that when we're compressing files, we're making them smaller. Sometimes that will mean loss of quality. Sometimes it will mean we can keep the quality. That's what you need to know. So what have we learned? Files are compressed to save space and increase transfer speed. That's why we do it. The lossy compression means that we are losing quality, but with lossless compression, the restored file has the same quality as the original. Do pause the video to see where you feel your knowledge is now with compression. Once you've done that, if you fill out the slip in your green book, and I hope that you have made progress with compression in this video. Thank you.